bunch of ways to define what open data is. I'm going with one of the simpler definitions that tend to be employed. So the first is the idea that you ought to be able to have access to it. If the public cannot access that data, then it is not public. The second is that computers have to be able to understand it. So, for instance, a PDF, an Acrobat file, a computer can't peer into that and see what is in that file. It's just a bunch of pictures. So if you were to take, say, a spreadsheet, save it as a PDF, it ceases to be a spreadsheet, it ceases to be numbers. Now it's a series of pictures that are of no value to a computer. The third is without cost. If you're charging for it, it's not open data. And the fourth is that it has to be possible to actually do something with that data under the licensing restrictions. That is to say, if there are restrictions that say you can have this data, but you can't show it to anybody and you can't change it, well, that's not open data. It's open information, but it's not data. And I'll go into the distinction there here because I think it's useful. So let's go back to the start of this concept of open data. And that began really functionally with the National Weather Service back in 1870. U.S. the Congress wanted to establish a national weather service. They needed some way to start sharing weather information. And the reason was this. It became clear with the advent of telegraphy, of the ability to communicate really fast, that you could say, hey, there's a really big storm here, and send that telegraph 100 miles east, and a little later in the day, they get a big storm. They figure, there are weather patterns, and things move in a predictable fashion. And the reason that they wanted some sort of a national weather service was it became clear this was really valuable for commerce. That was the purpose of a national, not to know like if you need an umbrella tomorrow. It was largely for shipping, especially along the waters. So initially, the National Weather Service existed just for the Atlantic Ocean and the Great Lakes. The Great Lakes were like a really huge shipping vector at that time. It was a big deal. And the idea was if you knew that a big storm was coming, depending on your cargo and your ship, you could either get into port or if it's safer, get out of port. And the idea was this would save a huge amount of money in losses every year to storms. So they actually had this established by the Army, President Grant. And this created by the U.S. Army. Not because it was seen as a military thing, but there's no other part of the government in 1870 that had their act together to actually run a system like this with the precision and detail that was required. So in fact, they named it the Division of Telegrams and Reports for the Benefit of Commerce. So there's a couple things that's notable about this name. The first is they actually said telegrams. Like this was explicitly about telegraphy, not information or data. They were saying, oh, there's this new thing, the telegraph, and it's awesome, so let's make a whole department that's based on that. And the second part that's notable is saying for the benefit of commerce. So this, of course, is how we're accustomed to seeing weather data now. We see it on maps in a more open and useful fashion. This is how they described it at the time. I won't read the whole thing to y'all, but read it yourself. The point is, at the time, they called this the magnetic telegraph. That was the internet of the day. But they did something interesting in the 1970s. The way this information is provided through basically a telegraphic system stayed the same. In the 1970s, they established a computer bulletin board system, a BBS. Can I show hands, who has ever heard of a BBS? More than I thought. Who has ever used a BBS? Not that. Okay. So precursor, in the bad old days of the internet, it used to be, or even not even internet connected, it used to be that if you wanted to connect to what was then the equivalent of a website, you had to get the phone number for it. So imagine like getting the Weather Channel's phone number, and then you get your modem on your computer to dial it up, and you log in there and get whatever information you wanted, and then you hang up the phone, and then you call like your next website. It was a pretty slow process. So the National Weather Service established a BBS for weather, so that anybody in the country could dial up and provide their location, and it would provide raw weather data so that you get that forecast, because in the 1970s, like telegraphy is not really a great system for this. And that way you can get that information on demand. So this was the fuel for things like 24-hour weather, for all of the websites we have, every TV and radio station that provides weather updates, all that. They gradually moved the same system to the internet. It's the same raw data that's being provided, but over the internet instead of over BBSs. And note, there are no private weather satellites. All of the weather data that we get, that's all coming from the National Weather Service. There was an accidentally hilarious debate in Congress maybe 4 or 5 years ago with some well-intentioned congressman saying, we must get the government out of the weather business. It's competing with the private sector. And people like the National Weather Service said, oh my God, please don't do that. We have no idea of knowing what the weather is without the National Weather Service. So the National Weather Service was created to help commerce, and it now helps commerce in a very different but no less essential way. I think I now have 8 weather apps on my iPhone, one of which, the sole purpose of which, is just to tell me, hey, it's going to start raining in about 20 minutes where you are. That's it. That's all it does. It's really useful though, like, go inside or take things out inside so we don't get wet or whatever. The entire electric power industry is totally dependent, particularly in the summer, for dealing with peaks of temperature that need to be dealt with as people turn on the air conditioning. Trucking fleets, airlines, just-in-time delivery, this is all totally dependent on weather data. This is all made possible by the federal government opening up this data. So what would it look like, though, and this is an interesting comparison, if it weren't data? It would be, this is information. Not data, this is information. So here's the distinction. The only purpose that this can serve, what we're seeing up here, is exactly this. All you can do is read it at the top of the newspaper. You couldn't use this. If this was the only way government provided weather data, in the newspaper when you got it every morning, there could be no app telling you it's going to rain in 20 minutes. If you wanted to know what the weather was like in New Jersey, if you're going there tomorrow, as I was from Virginia, there'd be no way to know until you got there and looked at the paper the next day. It would be bad. Very few of the economic benefits that I described would exist. So by providing it as data, as machine-readable information that you can download from a website or from the internet and do stuff with, it's so much more powerful. So this is data. This is weather data. This is the conditions at the closest airport. I think 2 days ago was when I put this slide together. So this is called METAR. It's the Meteorological Terminal Aviation Routine Weather Report, and this is the global standard for weather data. So the interesting thing about this is that humans can read it if you learn to, but software can too. So let's see if I can get any of this. So KCDW is the airport code for the weather station. The next is, I think, the time at which I got, what's today's date? Yeah, so the first 2 digits are 13, so it's the 13th of the month when I got this. It must have been 4:53 p.m. When I downloaded it. I forget what auto means. I think the 05 KT, I think the wind was 5 knots. CLR is clear. That's all I can do. But if like amateur pilots or professional pilots, they can glance at this and they know what the weather is. So this was created back in 1968, and every pilot ever since has looked at one of these before every single flight that they've taken. Here's the same information in a modern format called XML. Humans can figure this out, and software has no trouble with it. But let's look at, even looking up at it, you should be able to understand a few things on here. So if we look towards the top, we've got, am I tall enough to point at things here? Nah, it's too high. Oh well. So you've got location, station ID, latitude, longitude, weather, temperature. I mean, this is all pretty, it's ugly. Like, you wouldn't substitute this for your nice weather on the 8th thing on the Weather Channel TV station, but it's pretty good. So humans can understand this, but software can understand it too. And that's awfully valuable, and that's an important overlap between information. Because many of us, if we had to choose between raw data of the weather and information in the form of like the note at the front page of the newspaper, we'd probably choose the front page of the newspaper because we don't know what to do with METAR data. But when you get to something like XML, you get to a form of data that's actually good for computers and good for humans, and it powers software and uses that are even more useful than just that raw data. So I just want to make clear that open data, it's everywhere. It's weather forecasts, yes, but it's zip code locations. Where is that zip code? Area code locations. Knowing where 202 and 212 and so on is. Our entire GPS system. But our GPS system was established for the military, and it was under Presidents Bush and Clinton that through executive orders it was opened up so that anybody could use it to know where they are exactly anywhere on the globe. And I bet most of us have GPSs in our pockets. I mean, that's like we live in the future. Like that's pretty amazing. So our entire shipping and transit system, much of our commerce is totally dependent on open data and all of these different forms. Especially open commercial data. All of our stocks exchanges. That's just huge instances of commercial open data. If you didn't know what the value of a stock was, I'd say on a second-to-second basis, but at this point it's by, I think, a millisecond by millisecond basis. Like our economy would crumble. This is really crucial data that we rely on. But open data is Also where you don't extend it, as I explained with our stop mark, there's things like product recalls, OSHA fatality reports, real-time earthquake data, an earthquake anywhere in the world within less than a minute. It's going to be, I think it's earthquake.gov, I think even the domain name they have now. You can get the real-time location of, I'd say every airplane, but that would be every airplane but one in the whole world. Every large ship in the world, you can see exactly where it is and where it's going. Even, and this is one of my favorite open data sets, 70 years of historical data from Marvel Comics. It's not quite open because there's some restrictions on it, but they have an API. How do I put that? They have, let's just say they have a website where it's possible, where even with software from other websites, you can say like, hey, could you give me a list of every cover that Jack Kirby drew? I'm not a comic guy. I might have just named somebody. Totally, I'm good. Okay. Okay. And it would give you like a list of all of the issues that he drew of every comic, or can you give me every storyline that involves a kidnapping? Boom, an instant list of all of them. For comic fans, this is huge. And because they've created it in a pretty intelligent, modern way, for people who use software on their computer to manage their library of comics, and this is a thing, like if you're a big comic fan, like you have desktop software, that can connect to that service. So suddenly what was software that only knew like what you typed in, now it knows everything about all of those issues, and your software just got way more valuable. Open data is in all kinds of interesting places. It's also not where we actually need it. Legislative data, laws, court opinions, municipal GIS data, lists of things like registered corporations, restaurant inspections, IRS 990s, FCC political ad spending, all kinds of open data that should exist comprehensively, don't. And if you were picking where to start with the value of open data, you probably wouldn't have gone with locations of boats or area locations. You might have gone with something more like our laws. But unfortunately, things didn't necessarily develop as we would choose them to. The last point that I want to make here is that open data is functionally the opposite of open. So open data is about preemptively providing people with the information that they need. And that might be the sort of things that you're sick of getting open requests for every week. Great, maybe that should just be provided so that people can, on your website, so people stop asking you for it. So Oprah is about responding to one request with one answer to that one person. Whereas open data is about anticipating what people are going to need, providing it proactively so that people can just come to your website and download it, have access to it, and not have to bother. So there are some improvements that open data can make over its ground. So I'll stop my basic introduction to open data there. Hopefully that's a good basis for some of y'all.
So my name's Rebecca. I work at the Sunlight Foundation. I'm going to talk a little bit about open data and its relationship to policy, both how policy can encourage better open data release in the future, and also how open data might eventually affect policy and how that's important. If you guys haven't heard of the Sunlight Foundation, we are a nonprofit, nonpartisan, located in Washington, D.C., working on open government issues, everything from money and politics to general open data, city work that I'm doing now. The way our organization is structured, we're pretty much third policy, a third software developers, a third reporting at this point. And I think the way the organization I work for is structured sort of informs how I think about open data and how it can be used, how to actually extract it and then use it, and how that affects policy and how it's like all a circle. These arrows actually don't make any sense, but it all works together and it's important. So Waldo touched on this. In the past, there's a lot of reactive open government data situations where you would make a records request or you would build a scraper for a website, which I don't know if we went into this a little bit, but where you build code that just goes over website pages over and over again, extracting the data and putting it into a structured format from this like semi-structured HTML format. Or then also, what I used to do before Sunlight was city planning work. And I remember like just finding data that my nonprofit didn't want to pay for and having to like retype all of those numbers into an Excel spreadsheet that was already in the PDF. So there's a lot of research already happening. There's a lot of extraction happening, and it leads to impact, but it takes forever to get this stuff together. One of the projects with the Sunlight Foundation is called Open States. You can find it at openstates.org. 5 years ago, I think one employee of the Sunlight Foundation started a project called the 50 States Project, And with a bunch of volunteer manpower, they started scraping each of the state legislative websites. Every state has a different website if you want to go look up the laws, and they're not consistent at all, and you can't find them all in one place. We started just as like a volunteer effort because we couldn't find funding for it because people weren't interested. But eventually we got funding for it and it took off, and now we have all 50 states and DC and Puerto Rico on one site, and you can cross-compare, find your representatives, and access and reuse it. And the best, that's us making open data that didn't exist before. It's like extracting it, making it structured. We also have an API for it. This is one example of something that was made with the Open States API. It's a specific like energy legislation tracker. A bunch of advocacy groups have used the Open States API. There's a good chance, like if you're looking at a New York Times article and it compares state legislation, they're actually behind the scenes using the Open States API to compare things. There's also paid for services that are similar. One of the side effects of going through and scraping a bunch of websites is we could sort of grade states how good they were doing in terms of their legislative data openness. New Jersey got a B, which isn't so bad, but it's also not good. Another tool that the Sunlight Foundation made is called Scout. Scout uses the Open States API and our Congress API and all of these different data sources that we've pulled, and then other sources have pulled, like we also incorporate the Court Listener API, which has a bunch of Supreme Court cases, all into this one app that you can go to scout.sunlightfoundation.com and play with right now if you want to. But it's a search engine just for laws, essentially, and regulation and court cases. And it's also an alert system, so you can find a keyword, say you care a lot about immigration, you put immigration in, you set up an alert, you get an email every time there's a new immigration law in Congress. Say you care a lot about energy in New Jersey, you can just put in the word energy and always get an update to your email box. You don't have to even go to Open States. I, since I work at the Sunlight Foundation, use a lot of the Sunlight Foundation tools all the time. So I track open data laws with Scout all the time. On May 12th, there was a bill that it passed the upper chamber. It hasn't gone all the way through yet. That is working on cyber infrastructure with Rutgers in New Jersey, and it mentioned open data in the bill, so I got an alert. There's a lot of different open data efforts going on around the country. There's like portals, initiatives. There's data online that's open data that doesn't know it's open data. They just don't call it open data. But there's also been like a surge, or a small surge that's like gaining in momentum of laws passed to make sure that this is a formal policy within government to make sure that you're opening up data. The first one was in DC, and it was like an administrative memo, pretty informal, and I live in DC, and they've been implementing it questionably, but since 2009, there's been several laws, I think 12 passed last year, 7 so far this year. Like, it's gaining speed. A lot of the big cities have some sort of open data policy on the books at this point. New York, LA just signed an executive order, San Francisco, Philadelphia, which Mark will talk a lot about, I'm sure. Just like a really quick rundown of what these open data policies might look like. The left-hand side is like their varying legal authority. Like sometimes it's a law, sometimes it's an executive order, sometimes it's an admin memo from like a city manager. Sometimes it's just an internal IT policy that doesn't really have anything official tied to it. Sometimes it's simply terms of use on an open data portal website. Like I would consider them all some amount of open data policy, with legislation being the strongest. And then we've also seen them like all over the place in terms of scope. Just yesterday, they introduced an open FOIL law in New York City. FOIL is their Freedom of Information Law Act, so they're going to have the idea in New York City, if it passes, they'll have a different portal where if people request things through old school Freedom of Information requests, that it'll go onto a website as well as to the person, which is cutting edge, very cutting edge. And then there's like general policies, and then we've seen some like really specific open data set laws introduced. There's a tax, like open tax data in Washington State. There's been some open law efforts in San Francisco and New York City. There's some open GIS laws in Minnesota. In Cook County, Illinois, there's a open budget data specifically in Oakland. New York City passed this webcasting law for all its public meetings. And a lot of these laws, they're sort of just like, they're guidance, and they need, all the points in them need to be implemented, but like it's gaining momentum. And then there's just like general like open government plans or pushes for open source procuring. One of the policy tools that I work on at Sunlight Foundation are the Open Data Policy Guidelines. Right now there are 31 provisions. They've gone through 3 different iterations. It's just guidance for if you pass an open data law or if you're trying to open a specific set. It's super normative in nature. Like we'd like to see people publishing their processes to create the data and then like all the possible formats and like specific metadata schema. Like it gets really into the nuts and bolts and weeds about what open data could be. And as these open data laws continue, it would be nice to see them get more granular and thoughtful. So the future is more proactive open government data. Data.gov at the federal level is trying to incorporate more of the local websites. Chicago did this data dictionary where they were pulling different data sets and they had tags, like sort of like very beginner linking. And then I have a screenshot of Al Vitelli, which is like the UK version of like an open foil situation. So there's impacts of reactive open data all the time. Researchers are typing in tables and doing really important reports. Some really quick impact examples of proactive open data from around the country. I have a few screenshots there. The Chicago Health Atlas just came out last week. This group Data Made in Chicago is like a group of civic hackers turned, Civic Innovators. The Chicago Health Atlas gathers a bunch of health information about what's going on in the city and then also points you to like health programs within the city at the same time. So it's like a really helpful site that's made by a third party, all with Chicago open data. The LA Times did this report last year on, or maybe it was the end of 2012, where they mapped the fire response time from the fire department in LA to see how long it took depending on where you lived. This is really important information that could change like the locations of fire stations and save lives ultimately. And then my favorite example that I bring up like in every single open data talk recently is there's a group called DataKind. They work with nonprofits and government and other entities on mashing up data. They're a bunch of data scientists for good sort of situation. DataKind. They used to be Data Without Borders, but then they got a cease and desist from Doctors Without Borders. Sure. But so they did this project where they held a hackathon, and New York City has all this open data. And they had open 3-in-1 data, and then they had like open pruning tree data from like a different set from like the Parks Department. And 3-in-1 data had fallen limbs and reporting fallen limbs, and then the Parks Department had pruning data. And they did their data science magic on it and proved that where areas were pruned like proactively, there was like a 20% less chance that there would be a fallen limb later on. So this is important stuff, and it could make a more efficient government. But that's an example. New York City had those data sets open. No one had just worked with it to like make the story out of it. So it's this idea of you don't know what you don't know, and opening up more data and having third parties work with it can be really beneficial to everybody. Just a couple more slides. I mentioned the Oakland open budget legislation. There's a group in Oakland, California called Open Oakland that does a bunch of like fiscal data viz work. And the Oakland City Council was so inspired by it and liked it so much that they passed like an open budget data to make sure that they had more consistent data going into Open Oakland site. So reactively opening data can sometimes lead to like more proactive open data efforts. And then open data can really change policies, like on top of like being about civic service efficiencies. There's an example with the stop and frisk data in New York. That was something that was actually like foiled for, but they got it online and they made it very clear that Some neighborhoods were getting stop and frisk more, but they weren't turning up more guns. And that's changed the way they're handling stop and frisk in New York. Recently, the big thing in DC right now is they're changing all the borders for schools. And in DC, we have something called ANCs, which are Advisory Neighborhood Commissions, like hyper-local government. And there was a period of comment that you could give your hyper-local government about how the borders were changing. Code for DC, the civic hackers in DC, took a bunch of open DC data and made it really clear how your border would change and how to comment in like a slick website. And this is third parties just using open data on really important issues that can affect a lot of people. So I think it's just important to reiterate the relationship between open data and all these other things that have already been going on. Reporting and policy, and how open data can make these more effective.
Who knows what an API is? Okay, an API just stands for Application Programming Interface. It's one of the many acronyms we use in the world of technology to feel important. Really all it is, it's a way to programmatically access information. That's really all you need to know. And Rebecca brought up a really important term, scraper. Anyone know what a web scraper is? I know a couple people in here who probably used web scrapers. So a web scraper, if you don't know, is a small program which is written to basically mimic what your browser does and go to a website and request a page in HTML format, which is the format that your browser turns into a pretty picture for your eyeballs. And what it will do is it will go through and it will pull out, scraping out the data and turning it into structured information. We see scrapers a lot when information is made public, as Waldo said, so it's formatted for people's eyeballs, but someone wants it for a piece of software or for their computer. So I just sort of wanted to hopefully reinforce this point here if I can. I'm going to do a live demo to add a little drama to the morning and see if this works. So this is, before I started working for the city of Philadelphia, I was working for a technology company and just sort of agitating for data, working with local civic hackers groups, much like Hack Jersey. And one of the things I wanted was, since I used the Philadelphia airport a lot, I wanted a way to programmatically access the information from the Philadelphia airport. I didn't want to pay for it. I had it on their website, and I knew where to get it with my eyeballs, so I wrote a scraper, and I scraped the data off, and I created my own API for it. Now, when I started to work for it, the airport was not very happy with that, by the way. Now, when I started to work for the city of Philadelphia, interestingly enough, they didn't report directly to me, but I had considerably more leeway convincing them of the merits of open data when I worked for them. So if this works, this is just a simple application that we built that will basically look up flight information. Now, it's not formatted for this screen very well, but what you can see here is basically an arrival flight number 710, Philadelphia Airport. This was formatted, well, there's another flight. There's a departing flight for Zurich, if you can see that down there, and the arrival flight is for Miami. So this is great, right? This is meant for your eyeballs. If it was obviously sized a little bit better for this screen, but this is the typical way that people will consume data. So what I wanted to do was actually use the same information, but I wanted to create it for machines. So this is a data format called JSON, which stands for JavaScript Object Notation. You don't need to know what that means. But this is an API for real-time information from the Philadelphia airport. So this is actual up-to-the-minute information. This is what's displayed on the big screens that everyone's looking at when they're running from gate to gate. So I get to sort of back into an explanation of what an API is. An API is sort of like a love letter. It's like a love letter for geeks on the internet. And like all good love letters, it should be easy to access, right? It should be easy to get. So you can sort of see in the URL here what I'm getting at, right? The number of the flight. I want to know the number. I want to know information on flight number 710, of which there are 2. I could also ask for, oops, I can't ask for arrivals. I can ask for all the flights at gate B5. I think I can do cities as well. All the cities that have flights can be, no, I can't do that. It's been a while since I used this one, I apologize, but you can sort of deduct how to get to information, right? So it's easy to get to. Also, like any good love letter should have really good stuff in it. It should be filled with good stuff. And you can see it's got a lot of really good stuff in here, right? It's got the date, it's got the status, which is probably the most important piece of information about a flight. But you can start to see why open data and APIs are really valuable and how they create value, because what I've got here is this last little element here. is the actual set stop. So this is the actual transit stop that we put in here as well. So that if someone, and as it turns out, there's also an API for transit information in the city of Philadelphia. So you can start to see how someone could start to assemble this information in a very useful way. If I wanted to know, if I was leaving Center City, Philadelphia, and I wanted to get to my flight number 710 to Zurich, I'd want to know what train I could take down to the airport, what airport terminal I wanted to get out at, and what the status of both my train and the flight was. And that's all possible now. It's all possible because we have an API with this information in it. So that's essentially what an API is. It's a love letter for people that write software. So what I wanted to do is to get into a discussion of why open data is important, why it's valuable, what we do with it, and then a discussion toward the end of this to sort of where we're going. So I don't know exactly where we're going, but I can tell you where I think we're going. You're free to disagree with me. You're free to call me out and challenge me. You know, I'm predicting the future here, or trying to, so I'm no better at it than anyone else, I suppose. But to reiterate something that Waldo said, he mentioned the National Weather Service. I always think of the Census Bureau as sort of ground zero for data, because the Census Bureau has been collecting data for a really long time, and they've been disseminating it for a really long time. I remember being a frazzled grad student reading the statistical abstract to the census, US Census, to try and pull out interesting facts. I'm pretty sure I read it with my eyeballs. I didn't use it programmatically. But if you can see up here, they now have the Census Bureau 2, which has petabytes of data. They're exposing it now as open data for downloading and through APIs. When I mentioned the transit information before, for a few years now there's been a standard for transit information called GTFS. And usually most major metropolitan areas that have a transit system that's heavily used use this standard for information. This really kicked the doors open on people creating things with information. It was meant to put transit information into Google Transit, and it was developed by Google, but it has basically spawned a cottage industry of people building transit apps because they realized, hey, I can take this information and I can actually do something with it. A lot of the people that I know that did this, the first people that did this in Philadelphia were people that were software developers that were commuting into the city from the suburbs. And they wanted better information than the SEPTA website gave them. So they took this data and they built their own app. And as a result, everyone now has an app that they can use. So early on in the open data movement, as we come to recognize it today, there were some app contests that started to happen. The District of Columbia got one kicked off. It was called Apps for Democracy. I think it was in 2008. Sunlight Labs actually had one or two. Both New York City and Chicago have done app contests. These are where governments or large organizations say, we're going to have a contest, come build something really interesting and we'll give you a prize and hold you up as a hero. From that, we've seen the development of what are referred to as hackathons, or hack nights, or data jams, call them what you want. These sort of less formal groupings of people that come together to work with data, usually data from their own community or data that interests them. It sort of happens under the auspices of just a local group. Hack Jersey is probably a great example of that. Just people that care about data and information and using it coming together. Happens a lot now. Happens all over the country and around the world, actually. And as Rebecca mentioned, we're seeing these external uses of data, these people that are using data outside government, driving the adoption of open data policies. They're pushing their governments to say, we want you to make more formal your commitment to producing data. So why is open data important? Vivek Kundra, who was the first CIO for the District of Columbia, and he went on to work in the White House, he had this phrase that I really loved. He said it was the democratization of data. It was bringing data to people so that they could do things with it. It's obviously foundational for government transparency. But what we see happening, the thing that's really building the demand for data is the abundance of cheap, powerful tools to do things with data, right? So everyone in this room has access to a spreadsheet program, either on their laptop right now or through the cloud via Google Apps. There are things you can do now with data that you couldn't do 10 years ago. So think about where we'll be 10 years from now and what we'll be able to do. That's really driving this demand for more data. It's possible to build some really useful apps. I'll show you a few that are my favorites from the city of Philadelphia in a minute. A lot of people are coming to the conclusion that it's a powerful tool they can use to drive innovation and even spur economic growth. I believe, like I said, you're free to challenge me on this, I believe that the future of the way we deliver services as governments is connected to open data. In much the same way that the internet changed the way that governments provide service and connect with citizens in the early to mid-90s, fundamentally changed the way we operate. data has that same potential, and I think we're starting to see that happen. Okay, so in Philadelphia, we have an open data community that actually came together and created this centralized site called Open Data Philly to put data that they were using, getting from scrapers, data that they were getting through right-to-know requests, data that they were getting through relationships that they had with people in various data communities, and they were putting it in one place. And this was really important because it gave people that wanted to use data a single place to go to find it, made data discoverable. And it gave them a way to have a discussion. It gave them a forum to talk about what they liked about this data, what they didn't like about it, and very often the additional kinds of data that they wanted. So this is a data set that was released in December of 2012. This is the Part 1 crime data from the city of Philadelphia. Lots of big cities doing this now. Crime data is data that is sought after. Lots of people want this information. It tells them, as Rebecca said, storytelling with data. It's possible to tell some interesting stories with this crime information because it's geolocated. You can connect an incident with a location. So let's look at some examples of open data, of things that are being built with open data in Philadelphia. There are scores of examples from all over the country on this. In the upper left is something called Philly Tree Map, and this is it's an app you can put on your smartphone, and you can actually pull up the urban forest. So it's a catalog of the urban forest in Philadelphia. If you are so inclined, and you want to update the measurements of the trunk of this tree, or the canopy cover of this tree, it will provide you with instructions on how to do that, and then crowdsource that information, basically send it back into the data store. And it allows us to actually look at how much water is being, I'm not a plant guy, I don't have a green thumb, but how much carbon emissions are being offset, all the benefits, all the good things that trees bring. It helps us estimate all that because we have readings for that. In the upper right is an app called Baldwin. It's named after the old Baldwin Locomotive Works in Philadelphia, but it's an app that uses real-time information from the Transit Authority, which is SEPTA, and it tells you based on where you are and where you want to go, the next 3 trains and what their status is. And this was a good day because everything's green. If it's within 10 minutes off of the scheduled time, it turns yellow, and then over that it turns red. Really handy, really simple, really powerful. It was built by volunteers in their spare time, and now is used by thousands of people in the city of Philadelphia. And down front and center is something that was built with the crime data that I just mentioned. It's a way that you can actually zero in on your neighborhood. Rebecca mentioned hyperlocal government. This is a way to hyperlocally analyze crime information. You can actually draw a circumference around the area you want to analyze, and it will tell you what happened there and the details of crime. Interestingly enough, this was something that essentially replicated what the Philadelphia Police Department was doing as a service to citizens of the city of Philadelphia. What they have done is they have scrapped their old webpage that did this, and they have now put this on their webpage. It was built by outsiders. It was not built by people that work for government, and it is now on an official government website providing information to the city of Philadelphia. Pretty impressive. So who's doing this? Who are these crazy people doing this stuff? A lot of the folks like this. This is at a hackathon at Temple University. It's people that grew up in an age when the tools for doing things with data were plentiful and cheap and easy to use. There are people that are used to not grousing about why there isn't a great app to find out when your train's coming, but they're used to building it. There are people who are used to contributing to their communities and to their city or their county or their state by writing software, using data, telling a story, writing a blog post. I mean, these are the kinds of people who we're seeing do this. It's also academics, it's journalists, it's anybody that wants to tell a story with data or to build something useful with data. And they're everywhere. So why else is open data important? Why are we doing all this? This is the question I used to get every day in my job as chief data officer from a commissioner or a deputy mayor or some department head who said, I'm already fighting budget cuts. I've got a legislative hearing next week. People are mad at me. My name's in the paper. Why are you telling me that why are you giving me something else to do, basically? So this is where I start to get into kind of where we're going with open data. So when we publish open data as governments, it creates an environment where governments think about the reusability of data. So they think about data as an asset, as something that has value intrinsically. And they start to think strategically about it. What can I do with this information? Who else could use this information? What it highlights for government officials is that creative uses of data often come from people that aren't close to it every day. They're people that they have some domain expertise, they understand the value of the data, what it means, but they don't live with it every day. They're not encumbered by these predispositions about what data means and what you have to do with it. And it also focuses investment on how we store data, how it can be reused. I can't tell you how many systems I've encountered in government that didn't give up their data easily, didn't integrate data easily. It was a challenge not just for open data, it's a challenge just for governance, it's a challenge for effective management. And we have it all over the place in government. So who here's heard of Amazon, the booksellers? So Amazon also has, in addition to selling books and other things, Amazon also has this little side business where they sell, essentially they sell computing power, the ability to do things with computers in the cloud. They actually run, I think they run the majority of the internet. I've seen statistics thrown out. They run like 65% of the internet is run on Amazon Web Services, it's called. So how did we get to Amazon Web Services? Well, the head of Amazon, a guy named Jeff Bezos, came up with a strategy where he basically said, we're going to communicate between our operating units, between our teams, through what we call services, or APIs, essentially. I'm getting really excited here. I don't want any memos, I don't want any phone calls, I don't want any informal communication. The way one team communicates with another is through this service interface. That's how you're going to do it. And we're going to build that up to the point where we can then externalize these and turn them outward so that customers can use them and they can build things with the same things that we have first used ourselves. The Bezos mandate, it's often referred to as. This was leaked on the internet by some disgruntled Amazon employee. It was really an interesting read, but I thought it was interesting because the way I think about it is governments that release data and information, they put it out there for external users to use. There are certain things you have to do well, right? You have to describe the data well. What is it? What does this field mean? What unit of measurement is it in? Is it updated? Is it complete? Is it accurate? All of those things you must do well, or people get mad at you and they say mean things about you in online forums, or they send you emails that aren't nice. So if we're able to do that as governments, then we can internalize this data, and we can do a much better job of sharing data inside of government, between governments, between the departments of government. Because the only thing that governments do worse than sharing data externally is sharing data amongst themselves. And I'll give you a really great example of that. So in the city of Philadelphia, we have a typical problem of stovepiped departments. We have one department that actually assesses the value of a property and grants an exemption against that value. And we have another department that reports to a different deputy mayor, of course, that levies the millage rate against that value and collects the property taxes. There is no way that agency doesn't share their information. They don't make it available to, in a way that's using those internet love notes that I mentioned, APIs, using open data. They make it available for eyeballs. You can go to a website and look up your property and see what the property tax balance was. But there's no bulk access to that data. They don't share it externally to journalists or researchers or hackers. And as a result, they don't share it internally. It just isn't available. So when you look at what our Department of Licensing and Inspection was doing, and you want to go and issue somebody comes up to a counter in the municipal services building in the city of Philadelphia and wants to get a building permit so they can put a deck on the back of their property, we don't check to see whether or not they owe us property taxes. We don't do that. So the team that I led in the city of Philadelphia went and looked at that over 10 years, and there were about 10,000 permits that were issued for building permits to people that owed us property taxes. They owed us in excess of $50 million, and this was at a time when we closed 19 schools in the city of Philadelphia because they did not have adequate funding. So the ability to share data internally is one of the rewards that we'll see down the road from open data. I always describe it as like an athlete that's training at altitude, right? The athletes go to the sports complexes in Colorado Springs because when they train there, they get very, very good at working in high altitude with low oxygen. So they're ready to break world records when they go to a normal elevation facility. So open data is like training at altitude for governments to get them to share information better amongst themselves, just to do their own jobs better. There was a really interesting study that came out of the Center for Technology and Government in Albany. And for me, it sort of highlighted. So this is what we're talking about. Where are we going now? What's going to happen in the future with open data? Here's what I think. I think governments are going to be less about, I'm going to build the website that you look at to see when your flight's coming. I'm going to be less about building the website you see to look up the value of your property. And what I'm going to be more is the enabler of that. I'm going to be a steward of data. I'm not going to be someone that actually is a developer of that end product. This is a radical shift for governments. Most government IT employees self-identify as the people that build these, finished solutions. Like, look, here I did it. See, this is the thing you look at when you want to know something about your government. So it's a real sea change for governments. It's a real abdication of control for governments. We don't control. City of Philadelphia's police department doesn't control what that website looks like that maps crime. They're relying, they're partnering, they're collaborating with an outside party to do that. And so it's a whole different mindset. It's a whole different approach. But I believe that that's where we're going. I know I'm going long, so I'm going to try and speed this up. There are some other platforms. GitHub is a platform that actually allows people to share software code. It's increasingly being used by governments to share data. What's really interesting about this is it's made to support collaboration. So when we think about sharing data on a collaboration platform, it raises the issue of, well, if somebody wants to take government's data and add value to it, and they want to send it back to me, what do I do with that? How does it affect the official data? And in the city of Philadelphia, we don't have a really good handle on vacant properties. This is not uncommon in big cities. Every department has their own list of where the vacants are and why they're vacant. The only way you can actually validate that is to ground truth it, is to have eyeballs on a property to tell you, yes, that property that you've got denoted as vacant is actually vacant. So it invites this feedback loop, if you will, for information to come back into government from people outside government. That's a very, very different way of approaching data management from the perspective of governments. So this is Philadelphia's home on GitHub. If you want to go there, it's github.com/City of Philadelphia. A lot of cities are doing this now. This is information that we share with the idea that someone will collaborate with us on it. We haven't had many takers yet. I hope that changes soon. Another quick example, this is some of the stuff we're sharing. Bicycle thefts, a lot of information that you'd expect to see, but it's open, it's available for anyone to use. That's my story. Like I said, you're free to challenge my vision in the future, but